Okay, we're back. Great. So next we will hear from my capstone team on using waste to power airplanes in Washington State. And our presenter is Laura Shutack.
Thanks, Suzanne. Hi, everyone. My name is Laura Shutack, and my team and I set out to answer the question, can waste power planes in Washington State? A question posed by our client, the Port of Seattle. So the Port of Seattle is a government agency which oversees the seaport and airport, and in 2012, they established ambitious goals. One of these goals is to be the greenest and most energy efficient port in North America. And to date, the port has made really significant progress to reduce their Scope 1 and Scope 2 greenhouse gas emissions. However, their Scope 3 emissions are by far their highest, and airplanes are the main source. So their goal is to reduce their Scope 3 emissions by 80% with a focus on sustainable aviation fuel, specifically using old t-shirts, bald tires, and anything else intended for landfill as a feedstock. So by definition, sustainable aviation fuel, which I'll now refer to as SAF, must be made from alternatives to fossil-based fuels with a focus on a reduced carbon intensity. As it stands right now, air travel accounts for about 1.9 to 4.9% of global CO2 emissions. And despite COVID-19, the fuel market is growing at 5.2%, set to reach $451 billion by 2026. And the aviation industry committed to reduce their net CO2 emissions by 50% by 2050. And while SAF is in the pretty early stages right now, the graph on the right projects that by 2040, these low carbon fuels will account for almost 25% of aviation fuel purchases. So why do we want to use waste to create SAF? And there are a couple of reasons. First, it's a reliable feedstock. It's projected that with a growing population, waste will continue to grow. Second, there is public pressure to close existing landfills. Third, there are financial incentives to divert waste from landfills as waste management is becoming more expensive. Fourth, in turning waste into fuel, producers are aiding the transition to a circular economy. And lastly, using waste to make SAF has a lower carbon footprint compared to traditional fossil fuels, which means that using candy wrappers and other suitable waste to power airplanes will work toward the Port of Seattle's goal to reduce their Scope 3 emissions. So how do we create SAF from waste? At the feedstock facility, waste is collected, sorted, removing recyclables and any materials unsuitable for conversion, which is typically about 50%. The appropriate feedstock is then processed at a biorefinery, and the fuel is mixed with traditional jet fuel. So we asked ourselves, how do we intercept the waste to landfill system, which is often managed by just one company, to finance a biorefinery and have a continuous inflow of waste? And while each county has their own system, most follow this general format for waste hauling. First, waste is collected and brought to a transfer station to be sorted. Then a second contract takes waste from that transfer station to a landfill. And at the same time, funds are flowing from households to the counties to waste management companies. When finally, at the landfill, waste is weighed, dumped, and charged on a per ton rate, also known as a tipping fee. So because there is not a biorefinery in the state of Washington to supply SAF to the Seattle airport, we researched the state of waste in Washington and case studies on existing biorefineries. We then conducted financial, contract, logistical, and policy analyses. And after gathering these findings, we made our recommendations based on the question, what can the Port of Seattle, a government agency, do to facilitate the creation of a biorefinery? So to start, we reviewed data from the Washington Department of Ecology, and there are 39 counties in the state of Washington, but just 7 produce over 62% of the state's waste. So understanding this, we reviewed the waste management contracts from these 7 counties, as well as the Portland metro area. And we included Portland because they use the same landfill as some of the high waste producing counties in Washington. Simultaneously, members of our team reviewed existing facilities, Fulcrum Bioenergy in Nevada and Enerchem Alberta Biofuels in Canada. And we found they have some shared characteristics. Both of these facilities convert waste into fuels. Both are located on or near existing landfills, and this proximity reduces the expenses of disposing of unsuitable waste. Both have secured long-term waste contracts to ensure a consistent inflow of waste. Both are incentivized by policies, and both have strategic investors, namely the Waste Management Company, among others. So using the information from the case studies, we concluded a biorefinery should be at or near a landfill with a maximum volume of waste. We analyzed the 4 largest landfills in the Pacific Northwest, which meet or exceed this volume, namely Cedar Hills, Columbia Ridge in Oregon, LRI, and Roosevelt landfills. The image on the right highlights that the output from the Roosevelt landfill would achieve 46% of the port's goal, the highest of any of the 4 landfills. And then for each landfill, we created a financial model and added an additional charge which would finance a biorefinery. We then analyzed how the charge would impact stakeholders. Specifically, would the charge affect the biorefinery's ability to pay debt? What would be the return to biorefinery investors? And of primary concern to the Port of Seattle, how does the creation of a biorefinery impact ratepayers? So we found that a new charge at LRI and Cedar Hills had the smallest impact on ratepayers, about $1 to $3 per month, and Roosevelt and Columbia Ridge ratepayers would experience about a $7 to $15 per month increase. And understanding that these fees can really add up, we recommend the port look into opportunities to reduce the impact on low-income communities through government subsidies or airline ticket fees. And while the Roosevelt landfill is closest to achieving the port's goal, some logistical considerations need to be taken into account prior to siting a biorefinery. Both Roosevelt and Columbia Ridge landfills are near natural gas pipelines, which are extremely critical to power the biorefinery. LRI and Cedar Hills are far from similar infrastructure and are near population centers. And after speaking with our client, there is strong public distaste for unsightly biorefineries and new pipelines so close to population centers. So not only would a biorefinery at the Roosevelt landfill have the highest SAF output, the landfill has the necessary infrastructure and low opposition. So next up is our analysis of waste management contracts from those 7 counties previously mentioned and the Portland metro area. State law requires each county to create a solid waste management plan every 6 years. And upon approval from the Department of Ecology, counties arrange waste management contracts. Presently, these documents are arranged by individual counties. However, one way to consolidate a large volume of waste, which is critical to the feasibility of a biorefinery, is through a regional waste management plan. This plan would be inclusive of multiple counties and reroute waste to a biorefinery. When we look at waste management contracts as they exist today, we found each county is a little different, but we did find some commonalities which would allow for financing and diversion, such as contract language, which enables counties to redirect waste for pilot projects and other reasons. Additional language, which allows counties to modify rates in responses to changes in laws. However, currently there are no incentives in Washington to divert waste. So to promote waste diversion, we recommend the Port of Seattle advocate for 2 policies. The first, for statewide waste reduction and diversion goals. The result would be amendments to current waste contracts with language requiring diversion to a biorefinery. A biorefinery could also benefit from financial incentives such as RINs from the Renewable Fuel Standard, but since this is already in place nationally, our second policy recommendation is to advocate for a low carbon fuel standard. When sold, these low carbon fuel standard credits will generate income and make a biorefinery a more attractive investment. So to summarize, we recommend the Port of Seattle convene appropriate stakeholders to advocate for a biorefinery at the Roosevelt landfill. A landfill here has the necessary volume, proximity to infrastructure pipelines, low political opposition, and is economically feasible. Production at the Roosevelt landfill would achieve 46% of the Port of Seattle's SAF goal. And to achieve the remaining volume, the port could advocate for statewide diversion goals. And this goal would then inspire a multi-county regional waste management plan, which diverts waste to the Roosevelt landfill. And working within the bounds of existing contracts, the port can collaborate with counties on diverting waste to a future biorefinery. And all the while, the port should advocate for a low carbon fuel standard, which would make Washington state an attractive environment to fuel producers and investors. So while we have recommended that the port do quite a bit, all of these efforts in concert will work to facilitate the creation of a biorefinery and work towards the port's goal to reduce Scope 3 emissions by 80%. So with that, I'd like to say thank you to Susanne, our faculty advisor, and our managers, Alex Abu-Hikima, and our deputy manager, Russell Hyatt. Thank you so much, and I'd love to answer your questions.
Thank you, Laura. I will open it up to the floor. Just want to encourage all our participants to ask questions. I know you're hearing a lot tonight from some of our professors, but really want to encourage your classmates to raise their hand. Our first question, though, will be from Professor Abdallah.
Hi, great job, great presentation. Question, earlier in about the middle of the presentation, you talked about an additional charge, and then that led to specific ratepayer increases. How did you arrive at that additional charge?
Yeah, that's a great question. And we base this charge on what would it take to finance a biorefinery, and in reflection of the current tipping fee. So each landfill charges a different rate to the waste haulers that dump there. And we found that Roosevelt, which would be the highest, has a very low tipping fee. So in order to generate the necessary financing capital to finance a biorefinery, we'd have to charge quite a bit more to make up that volume. But we do have that volume, that landfill does get quite a bit of volume. So it does make it the most attractive investment to meet the port's goal.
Thank you. Good job.
Thank you.
Okay, we have another question from Bradford Parker.
Hi, that was really an excellent, I can't wait to see this thing built. I'm sure it'll happen. I just wanted to know exactly, you spoke about sort of separating at the source and suitable versus unsuitable. What makes waste suitable for a biorefinery?
Yeah, so it's typically any household trash. You take out recyclables typically because they're higher value, in the state they are in. And then a lot of like yard and food waste is not so great because of the high water content. So materials like textiles, rubber, wood, plastics, that sort of thing are great, but anything with like a lot of water in it isn't so great.
Okay, great. Thank you so much, Laura.